Welcome to Study Guide Forum. Today we'll be looking at Gay Lussac's law of combining volume. If you are joining us, if you are just joining us, we are trying to look at Gay Lussac's law, and we will encourage you to leave a comment. We know that you are there with us. We're still waiting. If you are joining us, just leave a comment or you like it so that we know you are there. This is Study Guide Forum. We'll be looking at Gay Lussac's law of combining volumes of gases. What you'll be talking about this moment. Gay Lussac's law of combining volumes. All right. Just let us know before we go ahead in doing the this is not showing everything. I need to move it back a bit. Okay. All right, we are still waiting. Let's see how many numbers that will be here today. We are talking about Gay Lussac's law of combining volumes. All right, welcome. If you are just joining us, leave a comment so that we'll know you are there. Welcome. Today we'll be talking about Gay Lussac's law of combining volume. I will have a calculation there that we're going to be looking at, and we'll encourage you to stay with us. Thank you for coming around. Don't forget to leave a comment so that we know you're there. So what is this Gay Lussac talking about? We are made to understand that Gay Lussac really, in his law of combining volumes, that he states that when gases react, they do so in volumes, which is in simple ratio with the reactants, with that of the reactants, and to the products. And we'll have a question there we're going to be looking at, and perhaps we might be looking at some other questions. So other questions that will help us. All right, thank you so much. Thank you so much, Daniel. Daniel Obior, I can see that. How are you doing? So good to see you. It's been a while. You're welcome. You're welcome. So we are going to be talking about Gay Lussac, and then I think we can go ahead with what we are doing at the moment. You're welcome to Study Guide Forum. Like I said, Gay Lussac help us to understand the relationship that exists between gases when they are reacting. When gases they are reacting, Gay Lussac says that they do so in a volume which is in simple ratio with that of the reactants to that of the product. in that case, when you look at this, what it simply means is that, for example, based on the question we have here, the question is talking about the reaction between hydrogen and oxygen. I said I calculate the volume of remaining gases. The remaining gases can also be, it's what we call residual gases, because in every reaction that involve gases, there used to be residual gases in most cases. So in the residual gas, that's the residual gas we are asked to what? Calculate in this case. So when we look at this, the question says that calculate the volume of the remaining gases. If 40 cm cube of hydrogen reacts with 50 cm cube of oxygen at 100 degrees Celsius and 1 atmosphere. So now before you can solve this problem, the first thing you do is to write the balanced chemical equation. In some cases, the equation will be given to you, and in some other ones, they may not give you that. So here, this is a balanced chemical equation of what we are talking about. Now, based on the Gay Lussac's law of combining volume, what it means is that this ratio of the volume is telling us that 2 cm cube or 2 volumes of hydrogen will combine with 1 volume of oxygen to give us 2 volumes of what? Water. That is what we have. So according to Avogadro happened to also say something relating to this, but in another way, where he said that they combine in what? In molecules, in moles, which is in simple ratio with their moles of the reactants and the products. So here we have this. We are talking about the losers here. So what do we have here? If it's like this is the ratio that we have, the ratio of their relationship, volumes of their relationship. So the first thing you are going to do here is to find out the gas that is reacting in excess and the one that is not in excess. And the one that is not in excess is what we call limiting reactants. Is a limiting reactant. If you're joining us for the first time, we would like you to, subscribe to our channel and also leave a comment to let us know that you are here with us. We're so happy to have you around. And so let's continue. So how do we know this? How do we find out the one that is in excess? If you look at this, you have 2 cm cube and 1 cm cube. From here, let's see how many of them, which of them that is reacting in excess. So let's start from assuming all the volumes of hydrogen is going to react. That means you have 40 cm cube of hydrogen reacting with what? From here, that is okay. Let me go back. 2 cm cube. Okay, let's start right from there. Say that 2 cm cube of hydrogen will combine with 1 cm cube of oxygen. So if it's so, now 40 cm cube of hydrogen, what is it going to give us? It will be 1 over 2 times 40. That will give us 20 cm cube. 20 cm cube of oxygen. So in that case, you notice that all the volumes of hydrogen here will combine with 20 cm cube of oxygen, meaning that oxygen is in excess by what? 30. That is 50 minus 20 will give us 30. That is the excess oxygen. And then volume of this that will react, of oxygen that will react with this, with hydrogen will be 20. So at the end of the reaction, 20 cm cube of oxygen will go out from here, and then 40 cm cube of hydrogen will be used up. So now the next thing we are going to find out is, because we're talking about remaining gases, that means residual gas. The next thing we'll be talking about is the volume of volume of the water vapor that will be produced, because at 100 degrees Celsius and 1 atmosphere, water remains as what? Steam. That means gas. So from this chemical equation we have here, it means that 2 cm cube of hydrogen, 2 cm cube of hydrogen will then give us 2 cm cube of what? Of water vapor. So then 40 cm cube of hydrogen will then give us, this will cancel out, multiply 1 multiply 40, we have 40 cm cube. That is what we have. The water vapor that will be produced is 40. Now, because we are talking about remaining gases, the two gases that will remain at the end of the chemical reaction will be what? 40 cm cube of water vapor and 30 cm cube of oxygen. So in that case, the total residual gases will be 40 plus 30, that will give us 70 cm cube. That is 70 cm cube of residual gases. And this is what we have here. And if you have any question, you can leave your question. We're going to attend to your questions. Feel free to leave your questions there. And then if you're joining us for the first time, we want you to subscribe. Thank you for being part of the class. And don't forget to tell your friends about our channel. Thank you so much. Okay, maybe I will going to be looking at another question.